Welcome to our senior project, SkillCourt. Our mentors are Gomi Trastason and Jaime Borras. The developers are Sergio Saucedo and myself, Will Rodriguez. SkillCourt is a skill training simulator system for soccer players and coaches. Throughout this video, we will go over functional as well as the technical aspects of the SkillCourt system. SkillCourt focuses on solving the following problems. As we all know, soccer is a sport where team play is the main determinant of a team's success. When training, it is imperative to be able to engage in team practices which will mimic real game situations with other players. Not being able to train in this scenario really hinders the ability of going over certain routines which enhance the cognitive skills of the soccer player. Lack of an interactive training facility. Currently, the amount of interactive training facilities are in the low numbers. SkillCourt wishes to solve this by providing a top-of-the-line product line which will not only be fun but also accessible to the regular public. A lack of qualified training staff. Although it is possible to train by yourself, it is of great importance to train in areas which are tailored to your type of play. Whether you are a goalkeeper, defender, or midfielder, or forward, the need of a qualified training staff presents a problem to those looking to improve their skills when away from the training ground. One coach per team. Soccer teams usually come with only one coach to work on different aspects of a player's game. The current system presents some limitations. We currently have a mobile app which requires an Arduino controller and a physical pad to put to display of concept of SkillCourt. The SkillCourt 2.0 website has a lot of potential, but unfortunately, it lacks usability. It doesn't present a clear objective of the website for first-time users, and the wizard as well as the simulator pages contain ambiguous steps to create or play such routines. Throughout the semester, we used a software development methodology called Scrum, in which we divided the life of the project into sprints. Each sprint consisted of a span of 2 weeks, in which we worked on different user stories. As we can see in our Gantt chart, we had a total of 7 sprints, in which we worked on meeting the expectations for those sprints and be able to retire stories as the sprints get close to their end. Our requirements. Here, we have a breakdown of the main user stories implemented. A coach and a player user are both able to access their profile pages, add favorite soccer teams, retrieve an about page, and access our interactive tutorials. A player is able to view default and/or custom routines, and is also able to play such routines. A coach will be able to create, edit, assign, unassign, and delete routines. The coach will also be able to search for players based on certain criteria, as well as sign and release previously signed players. For our Android app, the coach does not interact with the system. The player is the one who interacts with the mobile app and the prototype of the pads. In this version, we focused on moving the entire site to an MVC architectural design pattern, which brings us to our 2 following stories. In this use case, a coach user will be able to sign players. We start this use case by logging in as a coach and accessing the players page. We end this use case when the user has searched for a given player and has clicked on the sign button. The signed player is now shown as signed. This use case embodies the interaction of different objects to achieve the objective of signing a player, as we can see from the following sequence diagram. Our systems actor requests players to the dispatcher, which then makes a request to the player's controller. This controller now makes the appropriate call to the models and gets the queried players. Once these players have been returned to the user then has the ability to request to sign this player. Once again, the player controller handles this request and it sends a request to the models to update the player's information. Once this has been completed, the controller updates the corresponding view and the user sees the newly signed player. Another use case, which embodies the nature of an MVC architectural design pattern, is the ability of a player user to retrieve default or custom routines. As we can see, this use case starts at the request level and it ends once the routines have been displayed back to the user. In the next sequence diagram, we see the different objects involved and how they interact with each other to display the routines list back to the user. System design. As it's been mentioned throughout the presentation, we adopted a model view controller architectural pattern with the intention of removing unnecessary complexity of the system and allowing the system to be easier to maintain. The actors of our system interact with our views, which then make requests to the controllers. These controllers then request the needed data from our models, and the models return the data back to the controller. The controller then decides to which view it should update, and then it will send it back to the user. System deployment. Hardware requirements. We need an Android device with Bluetooth technology, an Arduino microcontroller, and a PC with USB ports. This is to be able to run the Android app with our prototype of the pads to be used in the future. Software requirements. Processing.js was used to develop the wizard and simulators. PHP, JavaScript, jQuery, HTML, and CSS were used to develop the system. Parse.com was our back-end as a service, and Android Studio was used to develop the app. Persistent data design. We used an object-based storage in which we organize our data into different classes. As we can see, we have 5 different classes. We have a user class, which has all of the information pertinent to a user. We have a custom and default routines, which are created by a user of type coach. We also have a signed players class, which holds information of the users whom type is not coach and have been signed by other users of type coach. And lastly, we have our assigned routines class, which contains a relationship between custom and default routines as well as signed players. Security and privacy. This is one of the main reasons of why we decided to continue using Parse.com as our backend as a service system. It employs a strict service control at every layer from physical to application level. It also provides session management and encryption protocols over sensitive data. Now let's show our class diagram. This is our class diagram for the architectural pattern of the SkillCourt system, which makes emphasis on a model view controller approach, which was achieved by applying object-oriented principles for the development of the entire system. Main algorithm. In our efforts to control the entire execution of the site, we elaborated a dispatcher, which, as we can see from the following flowchart, handles all the inputs by the user that take place in the system. This goes from requesting pages to signing, unassigning, deleting, editing, or creating routines. Test cases. I will now present a sunny and rainy day case for the use case coach story. The purpose will be to test that a coach is able to sign players. We will begin by first logging in to the website as a coach. We will enter the following test data filtered by position and position attacking midfielder. And the steps to take is the user will click on the search button of the sign release player section, and the user clicks on the sign button in the actions column of a player. The test case ends once the user returns with a status of signed. Rainy day test case. Coach user will be able to sign players. We're going to test that a coach is not able to sign players. We take the same steps as the previous test case, with the difference at the expected result. The players list page will not load, and the status and action columns on the selected players will not update. User is obligated to reload the page and attempt to sign again the desired player. Our next test case is for use case user will be able to retrieve routines. Yet again, we're going to present a sunny case and a rainy day case. Let's start by the sunny day case. And our expected result is to verify that the user has indeed been able to retrieve either custom or default based routines. For the rainy day case, we go through the same steps, same requirements, with a different expected result. The routine wizard displays non-available routines for the player to play, and no routines have been assigned from coach. Now let's go over a brief live demo. Okay, let's start our live demo by logging in as a coach user. We will now access the wizard page. And we will go ahead and create a custom routine. Let's go ahead and select a couple of pads. It is important to make sure that we finish all the steps necessary before we go ahead and finish this routine. Go ahead and finish this step as well. Let's create a ground target. We finish this step and we click on Finish Custom Routine. Let's give this routine a name. Let's go ahead and click on Complete. And then this will take us back to the routines page. Here we can see the custom routine test we was just created. But now let's go ahead and assign a player to this routine. Let's assign it to I Will Rod. Go ahead and click Assign, and we now see that this routine has been assigned to I Will Rod. We will now log in as I Will Rod, which is a player, to see the newly assigned routine. Let's access the routines page. And right over here, we see our custom routine test. Let's click on it. Let's click play. And we can start playing. Awesome. We can also play default routines. Let's play the home chase. And let's click play. Let's just stop it. And that, folks, was a brief live demo of the coach and player modes in SkillCourt.com. Thank you.